Okay, 5.8, you have variation. If something varies directly or indirectly. And applications. Okay. Here we go. You'll have problems that are worded similar to what's in the book, so we'll just look at the book here. Find the variation constant and an equation of variation in which y varies directly as x, and the following are true. Okay? If y is 40 and x is 8. Okay. So if, let's write it, y is 40 and x is 8. Okay? Put y equals, k is what they write for the constant of variation, times x. Okay? So y is 40, x is 8. Okay? So divide by 8, and k is what? 5. So your constant of variation is 5. Y is 5 times as much as x is. And then it said to write an equation of variation. This thing that I write that with the 5 for the k. Y equals 5x, and that's it. You're done. This is your equation of variation. That's not hard, huh? Okay. What if you have one that's not exactly a whole number? Y is 54 and x is 12. So y equals kx, you put 54 is equal to k times 12. Divide by 12, 54 divided by 12. Let's not do a decimal, let's do a fraction.
4.5.
4.5, but let's do a mixed 9 halves, right. Instead of 4.5, you need to write it as a improper fraction, because you don't put like y equals 4.5x. It's always an improper, right? So we'll have 9 halves. If you want to, do it 4.5 and then go times that is 8 plus 1 is 9. If you want to turn it into mixed and then back into an improper, that's fine. Okay. I don't need those papers till later. Okay. So this is our constant of variation. What would our equation be?
9 halves k x.
Y equals 9 halves x. Right. Here's our constant variation. There's our equation. Equation of variation. Okay. Okay, let's do a word problem. You can even see the answer before we even do it. That's fine. Okay. Number 9. The number of aluminum cans used each year varies directly. So we know we're using the y equals kx. Varies directly as the number of people using the cans. Okay? If 250 people use 60,000 cans in a year, how many cans are used each year in Seattle, Washington, which has a population of this. That's a lot of things there, huh? Okay, let's write down the numbers and see what we're supposed to do with them. Okay. I don't know why we need to use N for the number of aluminum cans, but it says use N for the number of cans. Okay, so the number of cans varies directly as, this is the number of cans, varies directly as the number of people number of people using the cans. Okay, so you want to use X here, so it's kind of closer to what we're used to, or we could put P, whatever. The K you need there, that's our constant. Okay, it said that 250 people use 60,000 cans in a year. Okay, so how many cans are used in Seattle, which has a population of 563,374? I guess we don't really, it didn't ask for the constant of variation, did it?
No.
So actually, if it varies directly, it can be put into a proportion. You got people cans, people cans. So we don't even need the constant variation. If you did, you would put 250 here, 60,000 there, and divide by 250. So it would be hard to find, but we don't need it. Okay, so let's do the proportion people cans. 250 people, 60,000 cans. So 563, 374. How many cans? How do you solve that? Multiply, divide, right? $135 million, what? 209,000. Did you guys do it yet?
135209760.
760. That's the number of cans that you would use. If we did it using, sorry, this right here, we have 60,000 equals K times 250. What is our constant of variation? 60,000 divided by 250.
240.
240. So N equals 240 times K. 240 is K. 240 times X. X was the number of people. We should get that exact same answer if we do 240 times the number of people. $563,374. That was the number. So if you multiply that, do you get the same thing?
Yes.
Yes. So you could do that, make the equation, and then just plug in the number of people here and get it. Or you could do it, if it's direct, so if it varies directly, you could just do this. Okay, let's do another one. The weight, M, of an object on Mars varies directly as its weight E on Earth. So it varies directly as the weight E on Earth. A person who weighs 95 on Earth weighs 38 on Mars. Okay, so how much would a 100-pound person weigh on Mars? I think they want you to practice doing this way, even though we could set up a proportion. So we'll go ahead and do that on here. So the Mars is 38 K times 95. So divide by 95. So it's about a third of what they weigh on Earth. Right?
2/5.
What is it, 0. What?
4.
4 exactly? Oh, cool. So M equals 0.4 E, right? So if a person on Earth weighed 100 pounds, what would they weigh on Mars?
4 pounds.
4?
40.
40. They weigh 40 pounds on Mars. So it's 4/10 or 2/5 of what they weigh here. Okay, got the very directly? Kinda? Maybe we should do one with the tower. Okay, let's do one. Here's one says, find the equation of variation where y varies directly as the square of x. Okay? And find this when y equals 12 and x equals 2. Okay, varies directly. Y equals, you have a constant because it varies directly. The square of x, you're going to put x squared. Okay, we're going to plug in our x and y. Y is 12. X is 2. Okay, so 2 squared is 4. Divide by 4, what's our constant of variation?
3.
Our K is 3. So how would we write our equation?
Y equals 3 times x squared.
Right. Y equals 3x squared. You just put the K right there. If you want to see what it looks like on the graph, you put it on your graphing calculator and you see this thing that looks something like that. Now, let's do an inverse. Okay. Here's an example. It says, from the law of gravity, we know that the weight of an object W varies inversely as the square of its distance, it's d, which is the distance from the center of the earth. Okay, varying inversely, what you do instead of timesing k, you're going to do k divided by. Inversely will be a division instead of a multiply. Okay, so we write this as W equals, instead of times, we're going to divide by the square of the d, distance from the center of the earth. Okay. Let's do one where W is 3 and D is 5. The distance from the center of the earth, I wonder if that's, it can't be 5 inches or 5 feet or 5 miles. It doesn't say the distance, what it's in. It's gonna be 5 kilometers. It's still kilometers is about a mile. You think it'd be 5 miles only to the center of the earth? That doesn't sound right. 5, sheesh, I don't know. Yeah, okay. We'll have to figure that out and let you know what unit that's in. Okay, but let's do it where the W is 3 and the distance is 5. Okay, so the W is 3. K over 5 squared, right? Just put the 3 here and the 5 here. You probably guessed that, right? Okay, so we have 3 equals K over 25. How are you going to solve that?
Multiply it.
Yeah.
3 times 25.
It's divided by 25, so you're going to multiply by 25. So K is what?
75.
Right. So to write that formula, we have W equals, the K is 75, right? Over distance squared. So that's an inverse variation. We should probably do another inverse, huh? Okay, let's do y varies inversely as y. X, I'm sorry. Instead of the square, just y varies inversely as x. And let's do this when y is 14 and x is 7. Varies inversely means we divide after the k, not multiply, right? y equals k inversely as x. Okay, y is 14. I bet you thought it was going to be 2, huh? But it's not. Okay, so k over 7, we're going to multiply by 7, right? To solve it.
Be 98.
So what is the formula? Remember?
Y equals 98 over p squared.
Over x.
Oh, x, sorry.
Y equals 98 over x. You leave the y in x when you do the formula. You just put the k in there. Okay? You want to do another simple inverse instead of all the complicated ones? Okay. Still, y varies inversely as x. Let's do when y is, let me pick one here that won't be exact. Let's see. That one's exact. Okay, let's do when y is 0.5 and, or 0.1, sorry. And x is 0.5. So, y varies inversely as x. Y is 0.1, x is 0.5. So how do we solve that? Multiply. Times 0.5, right? So k is
0.05.
Okay, so this is our k. How do we write our equation?
Y equals 0.05 over x.
0.05 over x. Remember, leave the x and y. Just replace the k in this. Stand up, Philip. You're not writing, so you're falling asleep. You've got to move something. You gotta stand up and move around. You know what you can do? When I'm driving, I move my shoulders. It wakes your head up. It wakes your brain up. I've tried everything. While eating, drinking, water, loud music. The only thing that helps is air conditioner, but I freeze and that one's the one. Everything. I've tried all kinds of stuff. Moving my head, moving your head works too, okay? But when you move your head, the road goes like this, and you probably do too, okay? You move your shoulders, it wakes your brain up for some reason. I don't know why. Moving your shoulders, it wakes you up. Don't fall asleep with the drum. I'm always falling asleep, but I find it really bad. Okay. Now let's do something more complicated. You want another square of x? Y varies inversely as a square of x? Okay. Y varies inversely as square of x. Okay, let's do that when y is 0.15 and x is 0.1. Okay, y varies inversely, means you're going to put k over, right? Over what? Square of x, x squared. Put your numbers in there. Y, 0.15. Equals k over that squared. So put 0.1 squared. So 0.15 is k over, what's 0.1 squared? 0.01. To solve that, multiply by 0.01. K is
0.0015.
1, 2, 3, 4, 1, 2, 3, 4. There's K. What is our,
Y equals 0.0015 over X.
put the X in, X what?
Squared.
Squared, right. You gotta leave these like they were, just put the K in there. Is everybody catching on to that? Okay, let's get into something a little different, because you're gonna have to know it, so you might as well see it. See it for me instead of having to do the example. Alrighty. Y varies jointly as X and Z. Okay? So if it varies jointly, that means they're going to be multiplied by each other. Okay? X and Z, both of them. Okay, so let's do this when Y is 56, X is 7, and Z is 8. So for Y we put 56, X we put 7, Z we put 8. Seven times 8 is 56. Divide by 56. K is 1. So putting 1 there, you don't actually have to write the 1, do you? Just put XZ. Let's do one where it's not 1. That one was too easy. Let's do it different. Let's do Y. Varies jointly as X and the square of Z. Let's have Y is 105, X is 14, Z is 5. Okay. Y varies jointly as X and square of Z. Put your numbers in there. Y is 105. X is 14. Z is 5. Fourteen times 25 is what?
350.
Huh?
350.
350. So divide by 350, it's not going to come out exact, is it?
0.3.
We don't want a decimal though, we want a fraction.
3/10.
0.3 is 3/10, right? If you got that, convert it to a fraction, that won't reduce. So K is 3/10. So we need to rewrite this with our K. Y equals 3/10 X Z squared. Ah, here's a fun one. Right, okay. All righty, let's do this one. It really doesn't look fun, but let's do it anyway. Okay, 42. The volume of a given mass of a gas varies directly as the temperature and inversely as the pressure. If V is this, and T is this, and okay, let's write something down before we just say all these words that aren't meaning anything right now. Okay, volume is varying directly as temperature. Okay, it's varying directly with the temperature and inversely as the pressure. So the pressure is going to go on bottom. So converting that first sentence turns it into this. Does everybody see that? Yeah? Okay. If the volume's 231 cubic centimeters, we'll just put the 231. The K we won't know. The temperature is 42 degrees. And the pressure is 20 kilograms per square centimeter. This, oh, we might as well put it, don't matter. Okay, what is the volume when T is 30 and P is 15? So first we're going to find K and find the equation, okay? So we plug these in, let's find K, then we're going to worry about this other stuff, okay? Let's not worry about that now. First, if we've got 231 equals K times 42 over 20, first thing we would do to solve that is times by 20, right? Right? Okay, divide that by 42. And what do you get? Huh? 110? So our K is 110. Probably centimeters, but I don't know what the K is in. It's just a constant there. Okay. This is what we're going to have to plug back in up here, right? So write 110 and leave all the other letters the same. So V equals, I don't know what happened to it, I'm so sorry. 110 T over P. I'm getting it, I don't know why you aren't getting it. Okay. Okay, you got it written down? 110 T over P. Okay, I'll tell you what it said. It says, find, let's see, what is the volume, so we don't know V. Put V equals, what's the volume? And put 110 times, it says when the temperature is 30, so 110 times 30. You should be writing this down. What if I ask you what to do? What if I ask you what to do? You're not writing anything down. Temperature's 30 and pressure's 15.
Pressure's what?
15. So what's the volume? All you gotta do is multiply it out and get it, right? So what'd you get, Philip?
I've got my calculator.
220? So the volume is 220. Remember in the very first thing it said the volume was in cubic centimeters? The 231 it said was cubic centimeters?
So it'd be
So
220.
cubic centimeters, yeah. Cm to the third power, cubic centimeters. So the volume is 220 cubic centimeters. I think you'll be okay with everything else. A little bit of vocabulary you may have to learn in there, but. Questions? I think we covered quite a bit directly, inversely.
Do I have a whole bunch of